I don't even know if I want to respond, bro.
So what?
You, dude. Fucking been hitting you up all morning, dude. You just like
I
ghosting
heard
me.
you mumbling something earlier. I couldn't, bro. Have you ever stripped the floor?
Yeah, they have a machine
No,
for
you
that,
haven't.
asshole.
You
They have
haven't stripped the floor.
they have a fucking machine for that, dude. What are you over here using a fucking pole scraper like a moron?
You don't even know how to strip. What was scraper? What are you talking about, dude? You never stripped the floor.
Oh, you're talking stripping down the wax. I thought you were talking like linoleum tile or something.
Bro, there was only one guy in the whole upstate of New York that had one of those machines, and it was my boss. And even I was working before with him before he even got that. We were using a fucking pole scraper, bro. Tiles, glue down rugs. That shit was brutal. No, he actually then he upgraded and he had these machines. He had these machines with that vibrated crazy, bro. You'd be home after work running that shit for like 10 hours just vibrating.
Oh yeah, that's the
Now they
quickest
got
way
the
to get
ride on
fucking
machines. The shit pops. Well, no, now they
yeah.
got the ride on machines. That shit comes
No,
right up.
oh I know. We fucking rented one. I had this like giant motherfucker sitting in this tiny
For
little
like
fucking
30
cart.
grand. Yeah,
Have you
dude.
seen? It's it's like 24 inches wide, bro. No bullshit.
Yeah, bro. Before that, though, we were doing all those push vibrating ones. It was fucking crazy, dude.
Yeah, yeah. When we got into our house, man, it was all fucking glue down tile, dude, that we had to pull up. And yeah, I know all about it, dude. After I finished one bedroom, I'm like, nah, dude, I'm not doing this anymore. And fucking, we found a
It's
guy that had
brutal.
that right on paper, dude, and it was like night and day difference, bro.
Oh, yeah, you're done in 5 minutes with the ride ons. Dude, those machines are like 30 G's. That was fucking 15, 20 years ago.
You can rent them. They've got like you rent at places where you can pick them up and shit. They also got these things that work real good. They're called migrants. I don't know if you ever use one of those. You just like you pour beer in the back, dude, and the fucking thing starts right up. I think it's usually takes Modelo.
Bro, I'm about to be home in 2 seconds, and then we'll get it popping in here, all right?
No, I still got fucking 3 more jobs ahead of me, but yeah, I was wanting to talk to you about some stuff.
I'll be around. Give me 5 minutes, 10 minutes. Dude, that was actually pretty good. Celestial Theodolite thing last night.
You're breaking up a little bit. Yeah, I heard.
Like,
I heard. I heard Alan
they're
doing it.
getting closer than the globe every time. That's crazy. Distance and the mountain, the elevation of the mountain, and nuts.
Yeah, I really don't know how it all works, to be honest with you, dude. I'm like too scared to speak up and start asking questions and look like a fucking retard. Um, but it definitely sounds like they got something going on, and doesn't seem like the Globers are too hot to trot and trying to tear it all down. They're just kind of like sitting back. Jesse was trying, but he sounded a little more confused than he did anything.
No, that shit was hilarious, bro. Jesse fucking tried to cherry pick one, and it still ended up being the flat prediction matched better. Ruhif got it last night, bad, bro.
Oh, he came in here.
Yeah.
Oh, yeah, I was probably already in bed. But yeah, I definitely like what they're doing, man. They're putting in some work, dude. Fucking love it. What up, Alchemy?
What up, driving? Yeah, it took me a while to get the cell Theo down, man. Like, you gotta hear it over and over again. Well, like, basically, so you know that you get your first angle to the star through the height of the mountain. So that gives you one straight line of a triangle. And then you
The
know
hypotenuse?
the elevation of the mountain peak. Can you hear me?
Yeah, I cut you off. I said, is that the hypotenuse, the straight leg of the triangle?
I believe so, yeah. So you get your angle to the mountain peak through the occlusion of the star, and then you already know the elevation of the mountain peak, and so that gives you your two sides of a triangle. And so the only way to get the right answer is a flat baseline, because you can deduce the
Hold on, real
third
quick.
side of the triangle.
Real quick, bro.
If one side equals 180,
Hold
right?
on, man. Real quick, dude. So you guys know what a hypotenuse is. It's the side that's opposite of the right angle in a right angle triangle.
Right, it's the flat baseline. It's usually going to be the horizontal,
No, dude,
right?
no. It's the
No?
no, it's the side opposite of the directly opposite of the right angle. So you got a right angle triangle, you got a right angle. If you go 45 from that, that's going to be that line, that side of the triangle directly across is going to be the hypotenuse.
Yeah, so that occlusion, that distance, or that angle through the peak to the star, that would be the hypotenuse then, because your right angle is the peak of the mountain down to the elevation of the observer elevation. So we,
It's the longest side of a right triangle. It'll be
Right,
the
yeah,
longest side.
that's going to be the flat bottom baseline, isn't it?
No, dude, it's
yeah,
the
yeah, but we're
longest
kind of
side.
doing it backwards.
No, it's not.
We're
No,
doing it.
it's the longest side
I'm
of the
sorry.
right triangle. It's not the
Well,
bottom
it's
or
a
the one going up.
mathematical certainty, right? That if you know two of the angles, right, then you can guess the third angle. You have to have, what is it, like
Yeah,
180 degrees, all right? I mean, this has been a while since I did this shit, bro. I'm going back to 7th grade here, and I'm struggling, but it's something along those lines. Like, if you know the two angles, you can guess the third angle, because it has to equate to 180 degrees total or something, rather. I don't know. Help me out, Alchemy.
no, yeah, that's exactly right. Yeah, yeah, it was one of the things that Alan said last night. I think it was either last night or the night before in Ether Cause. But anyway, he said that it's hard to argue against Pythagoras, and that's exactly how simple it is. Like, there's one way to calculate, to get your 180 degrees or your proper distance, like the flat Earth prediction gets, because that's what we're doing is using the occlusion of the star to give us that first angle. So it's
Right.
kind of
And
back
then right.
because you're
I
using
heard
that to derive it. Because otherwise, without assuming the proper flat baseline because the Earth is flat, then you won't get the right distance. Does that make sense?
Right. Yeah, and you don't have a triangle anymore anyway. The second the second you arc that fucking line, that's not a triangle anymore.
Yeah, yep. That's another thing that Alan said too. Yeah, that theirs isn't even technically a triangle, correct?
Right. I don't know. It sounds like they got something. You know, hopefully they further expand that, and
I don't know. I think
you know,
Alan said something about another presentation today to further break it down because we were talking about it last night in the Ether Cause, how it needs to be broken down a little bit better so people can understand it because it took me a while too. I had to hear it over and over.
yeah, we almost need it like drawn out and shit, like a basic layman version, and then before you even get into the presentation, just so people are understanding of what the rules are here. You know.
I
Because
made
if
the
we're dealing,
suggestion. I don't know if it works out right, but it works out in my mind that we could make it something like Einstein's train, where if you're not the right distance from the mountain, then you'll get burned alive by lava or something. And you need to make the right prediction, otherwise you die.
well, it's just funny when they're showing the cross analysis of the globe model compared to the flat Earth model, and how accurate our predictions are compared to theirs. Um, that's just kind of like a fucking smoking gun, dude.
Yeah, accuracy matters, man. I mean, isn't that the point
Well,
of doing any of this?
this is the thing they try to tout and like hang over our heads about how precise the predictive capabilities of their model are, and how applicable it is for real world scenarios and such, and blah 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 blah. But it's like, dude, if we can show more accurate, precise predictions, then they've got to address that. They've got to succumb to that fact. Jeremy, you back yet?
I mean, the chat's been popping here in EA. I mean, if you've been reading the chat, and Alan and Shane in there and Jesse.
No, I don't do the chat really, bro. Other than to post some memes or something, a little bit of trolling. But yeah, I'm usually driving and working, so can't fuck with that. Plus, I suck at spelling, so I just kind of stay out of that. I usually gotta have Jeremy edit my text messages first. He proofreads for me.
So basically, if I remember correctly, because they assume a different angle on that third side of the triangle, that's why they get the wrong answer and a far more inaccurate prediction for the distance. Is because they have to assume an angle that isn't flat.
Now, is that a refracted angle or an actual angle? Because I think they were discussing that. How when you look out at the star, and make that observation, I guess it somehow eliminates refraction. It's like they're basically inferring that to be the actual and not the apparent location. And that part I didn't really get too much. Like I thought it was the other way around. Like when you're looking straight up, refraction's like basically minimized. You know, when you're looking at a zenith. But
Yeah, you have to be above like 15 degrees on the horizon or something. But the idea of using the star's actual position like you do in celestial navigation or from the almanac, that's giving you, where you're actually seeing the star. So that's how you get the correct angle and that you know what it is because you're using, well, they might call it an apparent position, but it's its actual position. And you get that by turning refraction off in stellarium.
yeah. So that kind of stuff I'd probably have to sit down and pay a little bit more attention to just to make sure it's all accurate.
Yeah, even Dr. Mike was saying that this stuff isn't, like what basically Alan kind of just figured out, I guess, with this particular distance thing is something that Mike knew right away when he introduced it to us. It's just that it takes a while to even absorb to get there, So he even
Yeah.
asked Mike that last night. He's like, "You knew about this right when you gave it to us, huh?" And Mike was like, "Yeah." And he's like, respect. That's, that was when he said it's tough. Fact remains, one prediction gives you the more accurate answer. And then Shane was saying that the reason that there is a slight discrepancy even in the flat Earth distances is because you're trying to get a star to occlude a mountain peak perfectly exactly. And so if the star is occluded like just slightly to the left or to the right because you're using such a precise elevation for that mountain peak that it might not be occluded at perfectly exactly that mountain peak. Do you see what I'm saying?
Yeah, depending on your geographic location between you and the mountaintop and the star. Is that what you're saying?
Yes. Yep. And that will give just a slight variation, because what you can do is you can make the observation first and just record it, with the time. And then you can go back and figure out which stars are being occluded by the mountain peak. So you're getting, as accurate as you can basically get it. Because you can just figure out which stars later are being occluded and then, do your math from there once you have the footage.
The problem I don't really understand is the whole celestial bodies like change their positions relative to the ground depending on seasons, don't they? Like that's the impression I was under. So I don't know. It almost seems like you'd have to, it's something that would only be able to be validated like annually if that's the case. But I don't know enough about, you know, the celestial realm to definitively say that to be the case. So
Well, they say that the stars shift by like 1 degree every 74 years or something like that. And then we know that to be false. One of the things was the Georgia Guidestones, that Polaris was through the hole in there the whole time and never moved at all.
oh yeah. I mean we've got sites in India, megalithic sites that were used for tracking the sun and celestial bodies that are still precise today without any deviation. So
Yeah, I was just reading about Gobekli Tepe, which is, they allege, is the oldest, megaliths that are aligned to stars, and they don't even want to admit, like, well, at least in the AI answer, that they still align. They say that they aligned during a certain period of time, like a 600-year period of time, something like 8,000 years ago. Or was it like 7900 BC to like 8500 BC allegedly it was aligned with certain stars, and it makes me wonder, well, it's probably still perfectly aligned. They just don't want to tell us.
Like I said, there's sites in India that you can go and verify for yourself that, still do what they were designed to do upon the creation of them without any deviation. So you got to know how to do it. Like, I think it requires some basic primitive tools and stuff to set it up, but the rocks are there, the notching in the rock is there, like everything's there. So I
Yeah,
don't
so I
know.
guess that by itself would actually prove that all the other megalithic sites would be aligned to the stars too. Because if the one wasn't aligned, then none of them would be. So if one is still properly aligned, that means all of them are.
Yeah, you could probably infer that, I would assume. Yeah. I mean, as long as they set it up accurately to begin with, then yeah.
Because I mean, even the people that built these structures were obviously paying attention to it for a long enough period of time. They would have noticed a precession or a movement of 1 degree every 74 years. I mean, if they were tracking comets and shit like that only occur, decades apart or whatever.
I just feel from like my own observations locally in my backyard, like I feel like the Big Dipper isn't always in the same spot, like consistently. Like I feel like it kind of not only changes its like orientation to me, but moves like within the sky. So I don't know.
What's doing a
I
big
don't know.
circle?
What's that?
Doing a big circle like everything else.
Well, yeah, that's what I'm saying. So it's like if all these stars are continuously moving, then it's like I don't know how you would be able to substantiate what Mike did, right? Going back to his actual location where he did all this stuff at, if everything's always moving. I don't know. What's up, Bacon?
Well, it's kinematics. It's perfect kinematics because the sky is in cycles, and the stars are all just circling Polaris.
Oh,
Hey,
that
hey,
doesn't seem to
Bacon.
be the case down here in the southern hemisphere.
Hey, Bacon. Boom dia,
What?
boom dia.
Bom dia. Oh, it's
Yeah.
actually afternoon, but yeah, same.
I don't know how to say afternoon, so you got to take what you can get, bud.
All right.
Boom tardes. I don't know if that works, but we'll make it work.
A bit. Okay, it's close to that. So yeah, someone was saying the stars go around Polaris. That doesn't seem to be the case where I live.
Well, obviously in the north they go around Polaris because Dieslow was specifically talking about the Big Dipper. But yeah, there's a southern center of rotation around Sigma Octantis is the closest star to the center.
Okay, well, what about Orion? Does it go over around Polaris or does it go around Sigma Octantis?
Orion, I'm pretty sure that constellation, yeah, those are all in the north, aren't they?
No,
I
half of
love
it's on
seeing
the north, half
Orion.
of it's on the south.
I love seeing Orion in the sky. It's the only one I can ever make out. Like I can do like Big Dipper, Little Dipper. Maybe I get them wrong and one's the other one, but I can always spot Orion if I can see it.
That's the easiest, yeah. It was also the first one I learned how to recognize, and then it was the Southern Cross, and then Scorpio. I think Scorpio is really easy too, but it's very big.
Yeah, so is Pisces. Once you recognize Pisces is very large portion of the sky, then you'll notice it.
Yeah, so like half of Orion is like on north of the celestial equator, and the other half is south of the celestial equator. So is each one of the halves are rotating around a different point?
It's all rotating in the same. It's all rotating in the same direction, right?
Well, he just said they go. Some stars go around Polaris, some stars go around Sigma Octantis. I'm trying to make sense out of that.
Is Orion all going in the same direction though?
I don't know. I want to know how he would describe the motion.
After
of
he
Orion.
describes it, I want to know how you would describe it.
Yeah, I would describe the whole sky as a sphere rotating around an axis.
It's all you. No, that's not what I asked. I said, would you describe it as all going in the same direction, all of Orion?
I'm not sure.
It's a soft block.
That's an oversimplified statement.
It's either is going in the same direction or it's not.
Yeah, but that's a bit ambiguous.
No, not really. It's very specific.
Okay, give me an example of a direction. Are you talking about left, right, east, west? What kind of direction you're referring to? Yeah.
The same direction as the rest of them. Is any one of
give me an example
stars,
of direction.
Is any one of Orion's stars going in a different direction than another one? How about
Depends on how you're reading their direction. You're going to get different values depending how you're interpreting you might get the same value. That depends on how you're reading their direction. Like, give me an example of a direction so I know which one you're referring to.
Part of Orion is going in a different direction than another part of Orion?
Again, that depends. Depends how you're measuring the direction. Yeah. For example, if you're using an axle of rotation, then you're going to get a single direction for all of them. But if you're getting an egocentric direction, then those are going to be different.
So you're telling me we see parts of Orion going in different directions than other parts of Orion?
Not at all what I said. I don't think you're listening to what I'm saying.
I did hear what you said. I'm trying to figure out if it's going in the same direction or not. You're saying there's a way to measure it where you can get one part of Orion going in a different direction than another part of Orion.
Yeah, if you...
Is that not what you just
said?
Is that what you just said, just to be clear?
I said depending on how you're measuring the direction, you can get different directions for those stars, yeah.
Yes, you could get them going in, but you could also measure them and get them going in the same direction?
Yeah, if you're measuring direction in a different way, you might get that.
Yeah, sounds like that measurement doesn't really do us a lot of good then. Sounds like I mean, I don't want to be insulting, but that sounds fucking stupid.
Yeah, they mean different thing. No, it's not stupid. It's when you're getting to something that is ambiguous. So there's more than one way to interpret it. So if you interpret in the X form, you get a certain value. If you interpret in the Y form, you get another value. Because they mean different things. Obviously, they're not going to give you the same value if they don't mean the same thing. Now, you don't want to disambiguate that. You want to keep both things with a single sentence, so it sounds like that's a contradiction. That's not a contradiction. Those are two things that mean different things. That's not a problem.
So in reality, are all of the stars in Orion's belt going in the same direction, or in reality, is one going a different direction than another one?
Everything I said is in reality. That in reality doesn't cut the ambiguation, doesn't make it so I know which kind of direction you're referring to.
The direction, pick a star that's moving in a direction, right?
You're just rephrasing what you're saying.
Pick a star. Can you pick a star in Orion, and it'll be moving in a certain direction, right? Can we do that?
Sure.
Sure. Okay, cool. So pick that star, and then is there any other star in Orion's belt that's going in a different direction than that star? Very specific now, right? We're very specific.
We're not very specific. You didn't specify how you're reading directions. Give me an example of a direction.
A vector. What you mean? You don't know what a direction is? If you don't know what a direction is, I don't even know if we can have this convo. I'm good. You're not.
I do know what direction is. Well, you could be talking about egocentric direction.
Clearly.
Yeah, I know what a direction is, but a direction could be egocentric.
Why are you playing stupid games?
You could be talking about.
Why are you playing games if you know what a direction is?
Can you not interrupt me? Can you not interrupt me, please?
I'm just wondering why you're playing games if you know what a direction is, and we're sitting here going through.
Yeah, I'm not playing games, and I was mid-sentence. Yeah, I know what the
Sounds to
direction
me like
is,
you're
but
playing
you
games.
could.
I don't know. If
He's
anyone
Can I
else
not
telling
wants
get
to
you
play games,
interrupted?
he's telling you
Can
there's
I not get interrupted?
qualifiers. Yeah, he's telling you there's qualifiers. You just don't seem to be listening to what he's trying to tell you. Is that right, Bacon?
Yeah, I guess so. There might be a way to phrase what I'm trying to say to him.
Why wouldn't you just say it's going straight east to west?
Because it's not. East to west are horizontal directions. Unless you're talking about the GP of the stars, then of course, yes, they're all moving east to west. But if you're talking about like the direction in which we see the stars from the ground, then that's not east to west. You could say that's left to right or up and down, or you could even use like azimuth and elevation to describe their direction. If you do that, of course, you're going to get different directions for each star. But I was talking to Angling Alchemy, and I had a question. Jeremy said he was going to ask me after I got the answer, but I never got the answer. But he turned off his microphone. I'm not sure he's still here. Yeah, it doesn't seem so.
You talking to me?
Yeah.
What up?
Yeah, I'm trying to understand how you think the motion of Orion happens, like the southern part and the northern part of it.
I mean, I guess I'd have to take a look at it. I don't. Maybe could you elaborate further on your question?
Right. So you said northern stars go around the North Star, and the southern stars go around Sigma Octantis, right?
I mean, you're just colloquially, yeah.
Right. So they're going around different points, 2 points specifically. And
Okay.
half of Orion is on the north part of the sky, and the other half is on the south part of the sky. So if I try to picture that happening like on a dome where there are 2 points and half goes around one point and the other half goes around the other point, I think that Orion would split apart, right? One would go towards the north, the other would go towards the south, and you get Orion splitting apart. At least that's how I'm picturing it.
Yeah, I see what you're saying there. Probably has something to do with our personal atmospheric dome and the limits of your vision, because you can only see so much of the sky at a time. So what you're doing is you're thinking of the whole model, I think, all at once. Whereas we don't see it like that from our perspective. It's just how we interpret it. So like, and you know, I posted something in the chat that kind of illustrates, polarity in a magnet, I guess, and how that's the same thing we see in the sky. No, there's something else I was going to say. I just lost my train of thought.
Yeah, but in that case, like if you check, there's a point where those two circles meet. Let's say Orion's there. As soon as Orion move away from it, it would like spread, right? Like, but we can see Orion for the whole night, depending on the time of the year, and it doesn't get stretched or anything. Stars are like equally distant from each other the whole time. They don't get any further away from each other or any closer.
Yeah, here I actually have a picture. I have a graphic. I have a picture that shows exactly what you're talking about, and I think it'll be helpful here. I'll put it in the chat.
All right.
So this is like what you see when you oh, okay, that's not the one I was thinking of.
I'm guessing that's a 360 photo.
Yeah, that's not. Yeah, I was thinking of a different graphic, but I guess that shows kind of the same thing.
What it?
But see, we're not actually, you know. So that dome you're talking about, where you think about it splitting, that's just how you see in a dome around you. You know, your azimuthal grid of vision. Optics are really hard to understand. That's probably one of the most difficult things to put into words and try to understand what's going on, especially when we're talking about the sky.
Oh, I just don't see how Orion isn't getting stretched.
Yeah, I guess it crosses into the territory on what you think the sky is, you know. Because I personally think it's a lens, I'm not aware of its properties,
Right.
I don't know. Man's been mystified about the sky forever. Nice globe proof in the chat from Rich. That's the only place you ever see any curvature really is in the sky. You know that, right? And that the sky doesn't corroborate itself.
The sky doesn't what? Sorry.
The sky doesn't corroborate itself. It's the only place you're measuring curvature. It's completely optical and it's all above the horizon.
I don't think we're measuring curvature from the sky. Oh, are you referring to curvature of the Earth?
Well, what it's interpreted as curvature of the Earth is the result of a spherical coordinate system. Because we see in a sphere around us, because that's how optics work. So, let's say, you go to your Weather Channel app or whatever, your weather app on your phone today, and you look, oh, today's, a little bit hazy out there, so your visibility is only 5 miles or whatever, And so if you stand somewhere in a circle and do a 360, you can only see 5 miles around you. And so you just created a circle with a 5-mile radius. Same goes for when you look straight up above you. That sphere you create around you with the limit of your vision is indeed a sphere.
Are you saying there's some limit to how far you can see in all directions? Like a fixed distance in all directions?
No, I was just using that as an example to be able to illustrate how you see in a sphere. You're
Yeah, I
within a
understand that
dome.
if we consider the collection of everything that we can see from a point of view, like all directions that we can look at from a certain point, then all those directions combined form a sphere. I get that, yeah.
So that sphere that you see in the sky is then translated to the ground by you create a coordinate system. That's how obviously even ancient traveling happened, was they were watching the sky and how the angle of the stars. And so it
Yeah.
makes sense to turn that into a spherical coordinate system because you see in a sphere.
Oh, but it doesn't have to
But
be.
by the same token, you could turn that coordinate system into anything you wanted. You could make it into, some type of polygon or something and still be able to accurately navigate to where you wanted to be.
I disagree because I tried that.
You don't think
What
so?
you just said,
Well, then
I
why do we
tried it.
use flat maps that work? Every map, when you pull out a map and you look at it, it's flat. And so,
Yeah, give
you
me,
know,
give me.
ancient people didn't think they were traveling on a sphere, dude. They were just using the stars in the sky with a flat baseline to be able to
Well, they also
navigate.
weren't using latitude and longitude. That's a bit modern.
Yeah, we can get into all that if you want, but
Sure.
yeah, the fact remains the spherical graticule is just a coordinate system that was originally extrapolated from the sky. There isn't anything about the ground that was measured that says that the ground is curved. I mean, we've been over this how many times? We can see way too far, and refraction is nowhere near a good enough excuse as to why. And it stands to reason, and it fits Occam's razor better that when you're looking at a mountain from 120 miles away, that's a straight line sight, just like you'd use in a radio tower. You know, you need a line of sight,
Um,
a straight one.
yeah, let me ask you a couple questions. You think if, for example, there's a star overhead of me, and you follow that star, you're gonna end up where I am?
So there's a star above you.
Yeah.
We've frozen the stars in their place.
Yeah.
So that way I could find my way to you. I suppose
Yeah.
that
By
would
following the star.
it would it would it would depend on the distance. I mean, if you're far enough away that I can't see the stars that are above you, then I wouldn't be
Let's say
able
you
to
can
know
see.
where that star
Of
was.
course. Of course. Let's say you can see the star.
I would
Let's say
imagine that
Betelgeuse.
yes, I would be able to do so if you had a star at your zenith and I
If
followed
I'm
it
only
there.
seeing stars, I'd ask you why'd you hit them.
Good one, Dice.
Okay,
I
let me
would
change the
imagine, yeah.
scenario a little bit.
Okay.
Now, let's say there is a star at my zenith, and you see that star, but the sky isn't frozen anymore. So what you do is you just get the direction of that star, and then you go in that direction without turning left or right. You just go straight in that direction. Do you think you're gonna get to me at some point?
But you said the stars are moving now, but I did have the original position.
Yeah. So you establish a direction. For example, at a certain moment, I say right now the star is over me, is at my zenith. So you establish a direction of that star, and then you just go straight in that direction forever. Are you gonna get to me?
I mean, why wouldn't I?
Okay, so that means the direction of the star is also the direction of the GP, right? Does that make sense?
Yeah, I don't know if I don't know if I quite follow. I mean, I kind of understand what a GP is, but I mean, you
The
know,
GP is that point below the star. So if I'm below the
yeah.
star, then I'm at the GP of that star. So if we can establish a direction and then just go straight towards that direction without turning, we eventually get to that GP. Well, that means that the direction to the star is the same as the direction to the GP, right?
I don't know. I think we might be missing a no. That's a good question, dude.
Oh,
I guess I'd have to really think about it.
all right.
No, yeah, I would imagine so, dude. Because we use the stars. This doesn't matter, flat or globe, really, because it's all the interpretation of a coordinate system. That's all we're talking about. It's the same thing. So,
Oh, that does
like,
matter.
Polaris is in the same damn spot. Okay? So when you want to go north, you find Polaris, you follow that star, you're going to get to a certain GP. That's going to be the way it is. And that's going to be the same for Polaris as it is for every other star in the sky if you find that original position and you're able to maintain that heading.
Right. Um.
So, like I said,
Yeah,
it's really
that's
how
a
you
I think
interpret
that's a
how you
problem for
interpret the
flat Earth.
coordinate system. I'm
I think
sorry,
that's
what's
a
that?
problem for flat Earth. I'm saying what you just said, what you just agreed to. I think that's a problem for flat Earth.
Oh no, absolutely not. There's, I mean, tons of, you can go watch the videos on the spherical graticule, man.
Yeah,
Let me it's the
elaborate then.
same.
Let me explain why I think that's a problem. So, let's say there are two stars, right, in the sky, and you can point to one and then turn your body and point to the other. As you're turning your body, you're like doing that at an angle, right? So, for example, one star is at your right, the other star is in front of you, then they're 90 degrees from each other. Or let's say they're closer in the sky, so let's say they're 30 degrees from each other by turning from left to right, for example. That's the same angle to the GPs of those two stars, right? If you have to turn 30 degrees to face the second star, then the second GP is 30 degrees from the first one. Like the angle that you turn from one star to the other, that's going to be the same as the angle you turn from one GP to the other because they are in the same direction. Follow what I'm saying so far?
Yeah.
Okay. If you get 3 points on the Earth's surface, like 3 GPs of stars, and check those angles that I just explained, and add them up, they far exceed 180 degrees. If those were happening on a flat surface, those 3 points, those 3 GPs would form a triangle. If they form a triangle and you add up the angles, they should add up to 180 degrees, but they don't. They exceed by many degrees. So that means those 3 points can't be on a flat surface.
Yeah, again, you're interpreting where somebody is in their spherical limit of vision, and then you're putting multiple points on that. It's the same thing that, oh, what was the video? Dang it. So the stars merge below the horizon, and there's a negative coordinate system that you just interpret, but that goes beneath your feet. It's the same thing, dude.
I don't see how.
You're talking about the spherical. You're talking about spherical excess, which actually, it's funny how you guys will reference surveyors and shit like that. But did you know that surveyors sometimes get negative values, meaning that Earth in some places would have to be concave?
That's not what that means.
That's not even
I'm
saying on
aware.
a smaller scale, much smaller scale than you're talking about. But
No, a negative. If you get a negative value, that doesn't mean concave. A concave will also give you, like, if we were inside of a sphere, you'd still get positive excess. Being negative means it would be not a sphere, but a different type of curvature. It would have to be a negative Gaussian curvature. A sphere has positive Gaussian curvature. But that's beside the point, because I'm not talking about surveying measurements of mountaintops. I'm talking about azimuths of stars. And we're not talking about arcseconds, we're talking about full degrees here. What you're talking about, surveyors getting negative excess, that's arcseconds. That's like within the margin of error. So that's just noise. That's not really a significant measurement. But when I'm doing that with GPs of stars, those are degrees. There's no margin of error. Account for that. And I'm not talking about sphere of vision of anybody. I'm talking about the azimuths between GPs. Those are points on the surface of the Earth. Those are on the ground, on the sky.
again, yeah, that's the same thing. It's just how you're interpreting the coordinate system, and it goes right back to you're invoking the what the hell was the name? What was the name of it? I can't remember. Brain fart.
I'm not using any coordinate system to do this. Let's say we have 3 people. Each one of them have a star at their zenith. So each one measures the azimuth between the other 2 stars. If you add those angles up, they far exceed 180 degrees. There's no coordinate system being used here. We're just measuring azimuths and adding them up.
So let's call them 3 observers, right? We've got your 3 observers here, Bacon, making simultaneous observations of the sky. Follow me?
Uh-huh.
Okay, so none of them can see each other, and none of them can see the stars at their azimuth. Is that correct?
They can see the stars at their azimuth.
Okay, yeah, each one of them can see the stars at their own azimuth, but they cannot see each other.
No, but
The
they can
people
see the
can't see each
stars that
other.
are. Yeah,
Yes.
they don't see each other, but they see the stars that are above each other.
Okay. Either way, same thing. So this by itself, in this little scenario here where we've got 3 observers with 3 different stars at their zenith, and you're saying there's spherical excess, I'm saying that you are deriving that from the fact that you're interpreting the same thing. You're interpreting the curve in the sky. So when I move, just like the street lights in the street, what was the point I was going to make? That's exactly the difference you're talking about.
But I'm not doing any interpretation. The thing is, we have 3 points on the ground. If we connect them on the flat ground, that's a triangle.
Yeah.
If we connect
So
them
if
on the
I
sphere,
measure,
that's not a triangle.
if I did the same thing, assuming my spherical grid of vision, it would totally be a kinematic equivalence. I could interpret it the exact same way that you do and get the accurate results. This is one way that the globe is actually definitely useful. There's a reason they made it into a spherical graticule system, and it's because we see in a sphere with the sky above us, and that's how we navigate across vast distances here.
Well, that doesn't make a lot of sense to talk about kinematics because we're talking about a single moment in time. There's no motion, there's no speed, there's no velocity, there's no anything. There's no
It's a
kinematics.
measurement,
It's
though.
just
No, kinematics is measurement. That's exactly what this is. This is a measurement. This is an observation.
but kinematics is about motion. We're talking about a measurement that can be taken simultaneously, so there's no motion. Everything taken at the same time. That's a single moment. So there's no kinematics there. There's only geometry. And there's no geometric equivalence between a flat surface and a
You hungry at all?
surface. Those are
You hungry at
incompatible.
all? There's a spot that's
I
5
got him.
minutes
Hold
away.
on, Dieslow.
It's like a little.
I'm faster.
Okay, nice work.
Because I'm on a desktop, so on desktop is much easier. I guess you're on the phone, right?
Yeah,
Yeah, on the phone it takes forever to move somewhere.
it's brutal. It's brutal trying to mod on the phone. Yeah.
Yeah.
Anyways, carry on.
Just keep Dieslow muted forever, dude. Be easier.
Perma-mute him.
Just fucking ban him, Jerry.
Yeah, he's on the
Go ahead.
he's on the hot
Do
mic,
whatever you
actually.
guys were doing.
Yeah, angling, are you still around?
So this is maybe why the celestial theodolite is so important, because you can get right into the weeds with this, even though I just told you it can be a kinematic equivalence, because it's how you're just interpreting the data, because there's no physical measurement of the ground. And so, yes, this is why the celestial theodolite is very important in understanding why the flat Earth prediction makes the more accurate prediction.
Yeah, well,
A far more accurate prediction.
prediction of what?
I'm sorry, what was that, man?
Prediction of what? How do you predict an azimuth using flat Earth?
Oh, So, were you just not here for the celestial theodolite?
Not the whole time. I heard this discussion sometimes, but I'd never seen anybody talking about how the azimuth gets predicted. Actually,
Well, the
if you look at the, yeah, go ahead, sir.
Well, you're going to have to see the whole observation for itself and exactly what's been going on, because you sound like you're probably smart enough to be able to get it if you spend some time with it. So I guess I'd encourage you to do that. If you haven't seen it already and you're not familiar with what we're talking about, if I start telling you about it, I don't think
I'm
it's going to
familiar
catch
with
very well.
part of it. No, yeah, I heard some of it. So there's like an observation of a time where a star gets occluded by a mountain, and then there's some talk about whether that's accurate, if that matches the geometric position of the mountain, the refracted position of the mountain, so on and so forth. I'm not sure about what's the specifics on the argument, but I think I understand the general setup. But I didn't see anybody doing any prediction of the azimuth of the star for the occlusion. And I saw a spreadsheet. Someone shared a spreadsheet, and the spreadsheet uses the globe formulas for azimuth and elevation.
Oh man, I mean they already beat the horse to death. I mean I can explain it again, I guess, but they go
Are
through it
you
more thoroughly
familiar?
than I do. If anybody wants to go back on it.
Yeah, no worries.
There's one prediction makes the more accurate prediction. That's just the way it is, dude.
I'm sure that's what they're saying. I haven't verified that, and more often than not, they're incorrect.
No, bro.
Yeah, maybe they're
I
not this
mean,
time,
it
but
is.
yeah, I haven't seen the specifics to know.
So what they're doing here, this is what's going on. I'll explain what's going on, I guess. You're using the star to be occluded by a mountain peak as accurate as you can get it, because at the end you're going to find that, oh, flat Earth is off by just a little bit here, there, too, when it's way more accurate than globe Earth prediction. But the reason it's off a little bit is because you can't get a star to line up exactly with the peak from your observer point unless you're really trying, So you're going to get a tiny discrepancy there, whether or not it might be on the shoulder of the peak, because we know the exact elevation of the mountain peak at its very tippy top. So when you're looking at, oh, the mountain peak is at this elevation, that is actually the tippy top. And it's really accurate, I'm sure, within, feet or inches, maybe even. So you're using that to establish that angle to the mountain peak physically. And then you already know the elevation of that mountain peak. So that gives you two angles. That gives you two sides of a triangle. Now, if you have two sides of a triangle, you know that you know what the third angle is and what its distance will be. And that's where the difference is. Does that help you out?
Yeah, not much. Like for the star to be occluded by the mountain, they both have to be in the same direction, right? Same azimuth.
Well, it's at the very second that the star gets occluded, so it's like as accurate as you can get it. I mean, what was your question? Rephrase that.
Yeah, the direction of the star has to be the same as the direction of the mountain. If the mountain is to the left and the star is to the right, of course the star is not going to be occluded by that mountain. They have to be in the same direction, right?
Well, yeah, of course. What's cool about this is you can do it yourself, and it's actually relatively easy as long as you have the equipment, because you don't even have to figure out which stars you're looking at first. You can just go get some really good footage at an observation point of a mountain peak, in your area. And then you can go back later on Stellarium and figure out which stars are being occluded by the mountain peak, and maybe how closely they are to the actual peak, so that you could do your own observations. And
Yeah, but what I'm trying to ask is we have we know that the star in the mountain, they both have to be in the same direction. How do you get the direction in which a star is going to show up on flat Earth? Like, how is that computed? Of course, if you use Stellaris, Stellarium is doing it for you. But I want to know, like, how you do that, assuming flat Earth, using flat Earth to do that. Because that's not how Stellarium does it.
Isn't it funny how if you turn refraction off in Stellarium, it gives you the actual position like it says in this
Why would that be
the
funny?
almanac? Yeah, that's what's going on. Yeah, you don't know that?
I know that, but why would that be funny? The almanac doesn't tell you how high the star is from a certain point. The almanac just gives you sidereal, hour angle, and declination.
Yeah. Where you're actually seeing it.
That's not what those are. The declination of a star in Stellarium should match the almanac. Sidereal hour angle should match right ascension. That's it. None of those have to do with refraction.
No, absolutely it does. There's a sliding refraction bar in Stellarium, and when you turn it off, that gives you what we actually see.
I know, but that doesn't have to do with right ascension and declination. Like, that doesn't have to do with the data that you find on the almanac. Of course, Stellarium adds refraction to make it more close to reality. If you turn off refraction, that's going to lower the stars a little bit, and then that's not going to match a real life observation anymore. Not as precisely.
Say that again. If you turn off refraction, what?
The star is going to lower the position of the stars, so that's no longer going to match what we observe in reality.
If you turn off refraction, it's not going to match what we observe in reality.
Yeah, not the elevations. They're going to be a bit lower.
I thought you had to turn on a refraction so it matched what we see in reality.
That's what I'm saying. So if you turn it off, then it doesn't.
So it doesn't match. If you turn off refraction, it doesn't match reality.
No.
If you turn
That
off
was what I
refraction,
was-
it does match reality.
Well, when is there not refraction?
No, it's the other
Jeremy,
way
in
around.
Hold
reality?
on, man. Hold on. I'm trying to figure out what Bacon's saying right here. This is getting confusing.
It's not confusing. If you turn on refraction, then it's going to match reality better. If you turn off refraction, then it won't match reality.
Okay, that's it. That was easy. See?
But that's what I said every time. But in either case, the azimuths won't change. Either you turn on and off, there is no change in azimuths, which is what I'm trying to get to here.
Yeah. I don't dispute that. But we're working with Stungle. Well, maybe Alan will do another presentation today or something and explain it a little bit more thoroughly. Or in a certain way.
I
It
think the
took me a
Glovers
while
are
to get
trying
it.
to turn off the refraction for the celestial theodolite. I think they're trying to turn it off.
Yeah, the argument is if you turn off refraction, then that matches the geometrical formulas, because the geometrical formulas also don't have refraction. So if in neither Stellarium and the geometric formulas, if neither of them are taking refraction into account, then they should match each other.
So, in this celestial theodolite deal, what if I told you that Jesse's methodology and Ruhif's methodology weren't even the same?
Okay.
And I can't go into exactly the details on that because I don't know it well enough to understand it, but I watched it presented last night, and I thought it an interesting detail.
Oh, how
But
they
the
were both
celestial
getting different
theodolite,
They were both getting different predictions, you're saying? Ruh's prediction was different than Jesse's?
no, I think they're They might have been using a different route to get to the same answer. So, like I said, their methodology is different. And so
I think they
maybe
had
that can
a
be
different conclusion. I think Ruhif's predicted angle was different than Jesse's. I don't know. That's what it sounded like.
that was probably part of it too, really. But I remember specifically that their methodology was that Ruhif was doing something different than what Jesse was doing. And what that tells me is that the celestial theodolite, as it stands right now, is so rock solid that you're having to take shots at it, basically. Because it's actually really hard to refute that the flat Earth angle gets the right distance. Now, you're going to have to go into all the details on that and look into it, because it's hard to explain, just me to you, especially without graphics. Because, I mean, if you were in here yesterday, Alan, with graphics, was explaining it in here, and correct me if I'm wrong, but there's no way 100% of people got that all in one fell swoop anyway. And it's just like Alan said last night, there is nothing that supersedes the flat Earth prediction. It is the most accurate. There isn't another method or a way to get a more accurate distance in the scenario. That's just the way it is. And that's why it is so enlightening.
I don't really I don't know too much about optics, and they tend to do the presentations when it's like 2:00 in the morning for me, so I generally just leave anyway. But I I did listen to Shane and Alan both have a pretty good go back and forth with Doofus in here, and Doofus more than handled himself.
Yeah,
I'm quite shocked actually how much Doofus knows about celestial navigation. I had no idea.
yeah, he does. Like if it turns out Ruth and Jesse did different predictions, I will go with Ruth's. Jesse tends to do things simpler in a simpler way, and Ruth knows a lot about the nuances.
Yeah, Ruth knows a lot. But I was mentioning Doofus. Doofus actually surprised me.
Oh
How
yeah,
much he knows
yeah.
about trig.
Yeah, Doofus knows a lot about optics. But you're saying Doofus also know about celestial navigation?
Yeah, I felt he more than handled himself.
Right.
Very well.
Yeah. My only issue with him is that sometimes he starts shouting, and that's annoying.
Yeah, he gets a bit triggered, doesn't he? Yeah.
Yeah.
I mean, you put the effort in, hadn't you, Bacon, with the celestial nav, or what were your conclusions?
I did what?
You put the work in, right?
Yeah,
with
I did my
the
stuff.
Theodolites and whatnot, then
Oh, no.
Stellarium and all that good stuff. I don't know.
Yeah, I haven't got into this Theodolite, celestial Theodolite thing deeply yet. But I did go deep into the whole celestial navigation thing.
So when the FED crowd say it's measured flat and they're talking about celestial nav, why are they wrong?
Well, it's a very dumb argument. They're saying like when you pick up a sextant, you point to the horizon and you point to the star, and then you measure the angle between those two things. And they're saying that when you're pointing at the horizon, that's a straight line. So the surface has to be flat. That's basically the argument from FED server. That's just the direction of the horizon. That doesn't imply the ground is flat or anything.
Yeah, I always thought it were. I mean, again, you have to forgive me on my limited knowledge, but you can measure an angle in the sky, can't you? You don't need the floor. And if you were going along the floor, it'd just be a tangent anyway. Just be an imaginary line anyway. So what are they on about?
Well, the issue is with celestial navigation, we're trying to get your position on the ground, right? So you're gonna have to relate those two in some way. You're gonna have to relate your measurements to the sky to the ground to get a ground
but-
position.
Yeah, but you can just use an imaginary line, can't you?
Yeah, there are imaginary lines drawn everywhere when you're
So yeah, exactly.
doing
So I don't know.
like
I don't exactly
even
know
when
what
you're
they're trying to
surveying.
say.
Yeah, like even when you're surveying, many of the lines you're drawing to derive some math is going to be imaginary lines. Like when you draw a vertical line, that's an imaginary line. You don't have a physical vertical line. That's just an imaginary line. Like most of the lines we are using are imaginary.
I mean, I don't get. I'm happy to put my hand up and say I don't get it. You know, I've never done celestial navigation. If we get caught in a situation, you don't want to hand in me the sextant. Trust me. Give it
Right.
to someone who's more competent. But I just don't understand the argument as this is like definitive thing, unless they mean something else. When they say, I hear Nathan Oakley banging on about it's measured flat. Well, what is he on about? I'm pretty sure he's on about that, right?
Yeah, he says that all the time. Well, all that means is that the angle, because we're taking an angle with the sextant, that requires two straight lines. So one of those straight lines is Earth's surface, and that means Earth's surface is straight. That's essentially what that means. It's just not very compelling.
Speaking of straight lines, you guys see what I just posted?
I'm murdering
Well,
zombies, so tell us.
that's AI generated, right? That has to be AI generated.
Exactly. I asked AE to draw me how it would envision a canal 5 miles long with two boats looking at each other, right? And this is what
Right.
it came up with.
Right. Yeah, it says canal twice. One is in the canal, the other is outside the canal. That's a red flag for me. That's AI generated.
So what do you think of it?
What is there to think about it?
Do you agree with the AI's rendition?
Yeah, sure.
So you agree that in the middle of the five, well, let me tell you what it said. It said in the middle of the canal, there's a 3.1 foot hump, slightly curved, they said. So you agree with that?
It depends on how far the boats are, but given they're at the right distance, sure.
5 miles.
Yeah, let's just say that that's the right calculation.
So you agree with that then? All right. You know what else the AI says?
What?
It calls that line on top a chord.
No, that's not a
And
chord. The
I
straight
know.
line reference, it's saying that's a
I,
chord.
I asked. Yeah, I asked it to clarify, right? So then it said, "Oh yeah, well, thanks for the clarification." I said to it, "Are you referring to a straight line segment, maybe?"
Yeah, no, a chord is inside of the would be inside of the sphere
Yeah,
or the circle.
yeah. So then I asked it, "Okay, so knowing what we've discussed, whatever, show me how do you envision your rendition? Like, how do you envision the water in between two boats in a canal?" And this is what it came up with. So I'll post some of the things it said. And would you be able to measure that hump if you were to go from the side of the canal, let's say? Would you be able to measure the difference between the center and the two edges?
With a laser, I don't think a laser would form a straight line.
Well, let's say you made a straight line segment. You
Right.
agree that could be done, right? Over 5 miles?
Yeah, let's say that's done. If that's done, then yeah, we just get a piece of rope, and we can easily measure how lower than the line of water is.
So at the center, it would be higher, not lower, right? Than the two edges of the lock.
Yes, I meant lower, like in respect to the straight line. It would be less lower in the middle. So the
Yeah.
water is like 6 feet lower in the ends and 3 feet lower in the middle, something like that.
Okay. All right. Now, a lot of people on your side will not believe that, right? They say there is no such thing as it's level all the way through, right? But just looks that way or whatever they say, right?
And there, do you see what?
They say that there's no such thing as a hump in the middle in
But
a
that's
canal.
semantics. That's
Perfectly,
just
yeah.
I don't like that argument. It's just words. Like if you ask those people to draw a diagram and ask me to draw the diagram, we would draw the same thing. So it's just how they're phrasing it that changes. They don't want to phrase it like it's a hump.
Okay, let me ask you this. If both people at either end of the canal, right? If they were to like go on their knees, let's say go really low, below 3 feet, would the water block their view of each other?
Um, yeah, I mean, if we're ignoring any refraction, sure.
It would have to, right? The
Yeah.
water itself. Okay. Look at this one, Bacon. So it says you can make a perfectly straight line with a laser.
Yeah, that AI model is very newbie.
And look what it says about the canal's edge. Horizontal solid line represents
But it
the
also
canal.
says, yeah, and it also says constructed along Earth's curved surface. So it's saying a horizontal solid line follows a curved surface.
So dialetheism in the AI, no? I mean, program with a dialetheist. So, I mean, yeah, I was cracking up.
Yeah, like you gotta understand these models don't think, right? They are word prediction models. They try to predict what's the next word to finish that sentence. So they keep adding the words that they think should appear next. Like there's no reasoning behind what they say.
Well, it's a little bit more than that, right? They try to find what's out there, and they usually go for the standard wiki explanation. That's what I.
Because that's part of their training data. Like all of that was in the all of that determine what they think should go next. That's why it many times it's going to match what you find in the literature, but sometimes it doesn't because it's just predicting the next word and it might not match exactly something you find on the literature. But it does match the patterns that it learned. So it learns patterns and use these patterns to try to answer the questions. But it's not thinking. Like there's no reasoning behind it. That's why it took so long for these models to be able to do simple math. And they still get it wrong sometimes.
Yeah, well, it got a chord wrong, so.
Yeah, you get a lot of things wrong.
It contradicted itself in one sentence.
Yeah.
With a horizontal solid line. Yeah, that's too funny. I was cracking up.